All right. So what we're going to do today is we're going to be applying our transition matrix in scenarios now. So we've been just really much just looking at them, and we haven't been actually using them in the application process. So now we will do that today. So we have to remember our transition matrices, they're always square, and columns always add up to 1, and they'll call it T for transition. Now, what we're also going to be using is what we call is recursion, and recursion is just a way of writing it out or interpreting, and I'll show you what that means. So it's just way we express it using recursion. So recursion means how you get like reoccurring, getting the next one. So we're going to follow a pattern, and they will just use a certain language, and you'll see, or symbols, and that's what the recursion part of it is. We will do recursion also in finance because we can have a recurring thing happening there. So you'll see that word recursion. So consider the early example of going to the movies or staying at home. We can now ask the questions about the number of people we expect to be at the movies after week 1 and week 2 and so on. So what we're going to do is we want to keep on calculating where these people are shuffling around. So it's going to be annoying if we have to sort of keep like just looking in and calculating individually, and this is where the transitions will happen. So a recurrence relation can be found using matrices, which can model the change in the number of people choosing to change from week to week. The starting point for this example is a matrix that tells us how many people initially go to the movie and initially stay home. This is called the initial state matrix. So what a state matrix is just the scenario of where people actually are. So say, for example, this was movies and this is stay at home. So originally there were 200 people at the movies and 150 people stayed home. Now, the state matrix, so SO is the initial at the beginning. Okay, so we've got at the beginning. And then, because they're saying this transition applies from week to week. So S1, so if they said S1, that's going to give you the scenario of after 1 week. Yeah, so after 1 week, that would be what S1 represents. And you'd have a number there and a number there, and that shows you. So how can we use the transition to find S1? Is what we do is you can see we've got the transition matrix, and we times it by the SO, so the original scenario. So if you look down here, they've put the transition. Here's our transition matrices, and here was our original scenario. So if you're just looking at it and if you're thinking about, because you're multiplying, that's actually a 2 by 2 with a 2 by 1. So our answer will be a 2 by 1. So you can see they've over here, this is the manual calculations. But for a lot of these, you don't need to do that. You can just type this into your calculator. So if I show you on the calculator over here, so we could get our transition matrix. And so if we put in there 0.2, 0.4, and just double checking those columns are adding up to 1, which they are. So then you can go times, and then you can do the state matrix, which SO. So if I use SO, that will tell me the next state. So the one that comes after SO is S1. So you go like that, and there you go. So there's what they got the answer for. So then if we keep going, if we want to find S2, what we can do is we can use the transition times state 1, so which would be this new one. So if you want to do it on your calculator, you can just highlight that before. But what I want to do is I'm going to change this one to, oops, sorry. Oh, God, get out of there. Okay, I want to change this one to in here to be 100 because that's what, oh my God, I keep deleting it. Sorry. To 100 and 250 because that's what S1 is. And there underneath is S2. So then if I want to find S3, and then I can keep doing it like that. So that's recursive, what we call recursive. We are finding the next one by using the one before. So what we can set up, the way they can explain that or write that is here. So all you need to know is when they write this SN plus 1, that's just a way of saying how you get the next term. So how you get the next state, I should say, in this, how you get the next state. So if they'll say this and you go, okay, I can get the next state by using the transition and timesing it by the state before. Yeah? So we saw when we wanted to get S2, we use the transition by S1, the state before. So that's just a recursive, and then they'll say where SO is the original, initially what happens. Okay, so that's just what recursive language is. So that's all you need to know is just that's what they're talking about when they say that. So we're going to use this system, and we're going to follow these examples. So if we have a look here, sorry, just trying to get that in. We go, children at a fair can go on a Ferris wheel or a merry-go-round. At the start, 140 people went on the Ferris wheel and 80 people went on the merry-go-round. So you can see that's what them said, telling you your original state. So if you say 140 here and 80 children there, so we're saying this is Ferris wheel and this is merry-go-round. Now, if that's the case, if this is the order you're going to put your state matrix in like that, your transition needs to be the same. So in terms of Ferris wheel, merry-go-round, Ferris wheel, merry-go-round, like that, okay? So then it says down here, it says used to predict how many kids will go on each of those events or those rides after one turn and after 3 turns. All right, so that means, first of all, I want after one term, so which would be what we consider state 1. So the way I'm going to get state 1 is I'm going to use the transition, and I'm going to times it by the state before, which would be SO. So, which is that. So if underneath you just want to write, this was the transition matrix, and we timesed it by SO. So in your notes, when you're working these out, you don't have to write all the numbers. You can use the letter symbols and then just write the answer for it. Okay, so what we can do, so we're going to set that up on our calculator. So in here again, I'm going to pop in my transition matrix. So as a 0.8 here, 0.2, 0.3 and 0.7. Then I'm going to multiply it by SO to get S1, which was 140 and 80. So I do that. That gives me here. So this is S1. So this is S1, and this is Ferris, and this is merry-go-round. So if after one turn, I have 130 kids on the Ferris wheel and 84 on the merry-go-round. Now I need to get to S3, so I'm going to have to go in steps. So I'm going to go, all right, well, I need to find S2 first, because S2 is the transition times S1, which I have now. So I can move this number into here. So you can do it quicker on your calculator. So I'm just going to go up, highlight it, press enter, and then I just adjust these ones in here. Oh my God. Sorry, the computer's a bit sensitive. So, oh God, it's just not. Yep, sorry. So here we go. So I've put the transition times S1. I press enter. So we end up with our answer there. This is S2. So this will be S2, which is 134 now at the Ferris wheel and 86 at the merry-go-round. Now they wanted me to find S3. So I've got to do one more step, and I'm going to go the transition times the one before, which would be S2, and then we're going to get what we get. Okay, so we've done that. We've done the transition times the S2, and we found that it's 133 and 87. So this is the Ferris go-round and the merry-go-round. Now, it says to predict the number of children. So you can't sort of leave it like that. You do need to show your calculations like that, but then you would say after 3 turns, sorry, we've got the Ferris. You can abbreviate a little bit. So Ferris equals 132 and the merry-go-round, I'm just going to call it merry. That's fine. You can do things like that as long as you're making a little bit more of a statement that you understand what it is. So that's how you can get the next one using the one before. So you don't need to put all the numbers in, just your final answer, but you do need to put the codes there like T and S1, and you have to show me what you're doing in your calculations. So if we go down here to this next one, we've got, let's try this. It says, it tells you, let's use this recurrence relation. So all this is telling you, you can get the next one by using the one before. Okay, so let's go and do that. So we've got, it says after 1 and 3 days, so we've got to do this again. So S1 is going to equal the transition times the one before. So the one that comes before S1 would be S0. So you're going to pop that into your calculator again. So over here, I'm going to get a 2 by 2, 0.9, 0.4. Do the columns add up to 1? Are we checking that? Yep, they do. And then we're going to multiply it by a little 2 by 1. So these are the things, you can always keep saying these things in your head, and then it helps you learn facts off by heart and it makes you quicker in an exam and a test. All right, so there's the initial one. So then I find out. So this is what I've found out S1 to be. Now this was, I didn't read the scenario. It was predicting hot and cold meals. So this is hot and this is cold. Okay, so that's after the first meal. Then I want to get S2. I need to get S2 because I'm trying to get up to S3. So all I'm going to do is pop this number into there. It'll be the same thing except you're changing that number. So if I do that on my calculator, so once again, you just go up and highlight it. It is easier for you to adjust. I know I've had a little bit of sensitivity here with my display, but it's okay now. All right, so we press in that and we get this one. So we got 640 and 260. That would be hot and cold. And then if I want to go to S3, I'm going to use the transition times the one before. So with S2, so remember S2 is this one. So it will go into there. So let's quickly do that on the calculator. So we got 640 to go in here and 260. Okay, and then we get 680, 220. This is hot and cold. So predict how many after 3 days. After 3 days, so this state we've got 680 hot and 220